Inside an old clock, something is always being held back. A weight wants to fall. A spring wants to unwind. Gears want to spin until all their stored energy is gone. But instead of rushing to the end, the clock releases its energy in tiny, measured steps. We hear those steps as a familiar sound. Tick-tock, tick-tock. The question is not simply why a wound clock moves. A wound spring or a hanging weight can easily move gears. The real question is this: why does the clock move at a steady rate? Why does it not run wildly fast at first and then slow down? The answer lies in one of the most important inventions in timekeeping, the escapement. A pendulum has a natural rhythm. If it swings through a small angle, the time for each swing is nearly constant. That is why early scientists became fascinated by pendulums. They offered a physical ruler for time, but a pendulum alone is not enough. Air resistance and friction at the pivot gradually steal its energy. Left by itself, a pendulum would swing less and less until it stopped. A clock must solve two opposite problems at once. It must restrain the stored energy of the spring or weight, preventing the gears from spinning too fast. At the same time, it must give the pendulum just enough energy to keep swinging. The escapement does both. In a traditional pendulum clock, a toothed wheel tries to turn under the force of the descending weight or the wound spring. A small lever connected to the pendulum catches and releases the teeth one by one. Each swing lets the gear advance a small amount. At the same time, the gear gives the pendulum a tiny push, replacing the energy lost to friction and air resistance. This is why the ticking sound matters. Each tick is not just noise. It is the controlled release of energy. The escapement turns continuous stored energy into discrete pulses. The pendulum controls the timing of those pulses. The gears count them. The hands display them. Together, the system transforms mechanical motion into measured time. A common misunderstanding is that the clock creates regularity from nothing. It does not. The clock depends on energy stored in a spring or lifted weight. It also depends on the pendulum's natural period. The clock is accurate only because the escapement transfers energy without destroying the pendulum's rhythm. If the pendulum receives too much push, its motion may be disturbed. If it receives too little, it stops. Good clockmaking is therefore a delicate compromise. Enough energy to keep motion alive, not so much energy that the timing is corrupted. The same basic idea appears in many machines. A system with a natural rhythm can serve as a regulator, but it must be fed carefully. Too much interference ruins the rhythm. Too little energy lets it die. The wound clock is a lesson in controlled power. The spring or weight provides energy. The escapement gives permission. The pendulum sets the pace. Every tick is a small act of restraint. Timekeeping began not by making machines move faster, but by teaching them how to wait.